What's up? What's up? What's up? It's your boy, the network. And today's topic is subsection 3.1a, address types, Unicast, broadcast, multicast, and VLSM. This is a subsection topic under the section 3.1, identify, configure, and verify IPv4 addressing and subnetting. This is the exam CCNP ROUTE Exam code 300-101 version 2.0. Let's look at the exam blueprint and see where we came from and where we going. All right, this is the exam blueprint. Again, exam code 300-101. Make sure you are studying for the correct version. Now, I'm gonna keep repeating this until y'all remember that you're signed up for the correct exam and the correct version too. This is version 2.0. All right. They haven't taken off frame relay yet. They took it off CCNA, but it's still on the NP exam. So anyway, we are just wrapped up frame relay. Yep, it's still on here. 2.2C Charlie, multi-point. We are now finally moving on to layer 3 technologies, which is basically the meat and potatoes of this exam, because as you can see, it's 40% of the topic. So y'all really need to pay attention here. I'm going to skim over the subnetting part of this, but you know, we're going to go over the basics of this anyway, because if you studying for NP, you should know how to subnet anyway. Moving right along, we are currently at 3.1a, address types, Unicast, broadcast, multicast, and VLSM. And then after that, we're going to move on to 3.1b, ARP, which stands for Address Resolution Protocol. All right, so the different addressing types. As you know, I think I stated this in the, I believe, section 1.2 or 1.1, I don't remember, but it was general network challenges. We talked about unicast traffic, broadcast traffic, multicast, and VLSM. Now we got to learn how to identify those type of addresses, configure them on a router, and verify IPv4 addressing and subnetting. I'm not going to get too deep into the subnetting, but you know, we'll explain the basics of it. I'll give y'all like a simple analogy. So unicast address, as we stated before, a couple videos back, is basically an address that is assigned to a host, a single host, and it's traffic that most network traffic is unicast traffic anyway. It's just basically traffic going from one host to another host. That's it. I'll give y'all an example here. As I stated before, most network traffic is unicast in nature, meaning that traffic travels from a single source device to a single destination device. One computer on the left is pinging the server on the right, boom, and then back for a ping reply. That's it. It can't get any simpler than that. They are addresses assigned to a single interface on a device, or port, if you want to call it that, but an interface could also be virtual. That's why they said interface on this. They are used for one-to-one communication. One device, one interface, another interface, a loop back to a loop back, whatever. It's just one-to-one traffic. That's what they call it, one-to-one. Broadcast traffic. Broadcast traffic travels from a single source to all destinations, kind of like a radio signal. You got one source and broadcast it. That's why they call it broadcast. You broadcast it to a whole bunch of receivers. Broadcast traffic travels from a single source to all destinations in a subnet. That is a broadcast domain. A domain could be like a VLAN. A VLAN could be your broadcast domain. So you broadcasting it in that domain in VLAN 1. You broadcasting it to VLAN 2. You separating domains with VLANs, but we're not doing VLANs because that's layer 2 technology. You want to study that? Go to the switch exam. I'll start creating some switch. I already did that that exam, but we'll talk about VLANs when I do maybe some CCNA videos or something. But anyways, that's broadcast traffic. I'll show y'all an example of that in Packet Tracer. Yes, I love Packet Tracer. I don't care what y'all say. I can't. It's not easy to demonstrate on GNS3, being that my laptop is, I don't know, the fan even, it uses my processor a lot. As soon as I launch GNS3, my laptop, it just sounds like it's about to take off. So Packet Tracer is just a little easier. And plus, I love the simulation mode. I could animate this different type of traffic here. So we'll go ahead and show y'all that. Multicast traffic is addresses assigned to a group of devices on various subnets. So it's kind of like, this is more random. you can have a group of devices that is assigned to a specific type of address, and they will receive, if we send the traffic to this specific address, only they will receive it, a group of addresses or a group of devices, and the other ones won't receive it because they're not part of that group. So yes, it's a bit discriminatory, but that's what multicasting is. You use those for type of applications such as imaging, or some certain routing protocols get sent to a multicast address like OSPF, EIGRP. Those use a multicast address to send out routing updates. And I'll show y'all an example on that as well. The multicast address range specified by RFC 1112, I'll leave a link in the description, is from 224.0.0.0 through 239, 255, 255, 255. That's a Class D subnet range. And what else can we say about that? Yeah, that's basically it. I'll show y'all an example of that in Packet Tracer. Source there is at the bottom. As you can see right here, this video server is sending a multicast. Only they are receiving that type of traffic because they part of this group right here, the 239.1.2.3. This is just an arbitrary IP address. That's not something that's, only multicast. That's just an example. This guy, he's not part of that. He feels a little left out. Like I said, it's kind of discriminatory, but this is just something we do to kind of control specific type of traffic that we want. So VLSM stands for variable length subnet masking, the ability to specify different subnet masks for the same Class A, B, or C network number on different subnets. VLSM can help optimize available address space. Now, the way I like to explain, or when I think about VLSM addressing, is think about a pizza pie, right? So we got this pizza pie that we ordered, Domino's, Papa John's, whatever, and it's divided into 8 slices, right? 8 even slices, like we normally know pizza to be divided as, right? They all divided in the same sizes, and it's 8 slices, right? And we've got several family members, right? We got dad, we got mom, we got grandpa, we got the toddler, we got the infant, we got the dog. Everybody got obviously different appetites. Some people are going to eat more pizza than others. Some might not eat none. Grandma don't want none. She, it's going to hurt her heart. She got heartburn. She can't eat none of the pizza. So, now with these pizza slices, think of the 8 even slices as classful addressing, right? So let's talk about the difference between classful and classless. I can be considered classless because I could be ratchet sometimes. I like to listen to ratchet music. I like to listen to trap music. I'm classless. But in the sense of IP addressing, when classless routing or classless addressing is basically the uneven pizza slices, right? Whereas classful would be the even amount, the 8 slices of pizza. Now, if we go back to the regular 8 slices and we give everybody that same size amount, right? Dad gonna be like, oh, I need 2 slices, right? The infant, maybe she might just take 1 or 2 bites and that's it. That's a waste right there. He might eat too much. That's gonna leave somebody else out. Grandma, obviously she don't want none. We gave her a slice anyway. That might go to waste. So think of the 8 slices as classful addressing. We gave everybody the same amount. We didn't care who is hungry or who is not, who can eat and who can't eat. We even gave the infant some pizza. We tried to puree it and give it to the damn baby. We can't do that. So that's why it's wasteful. Let's go to this slide real quick. The difference between classful and classless addressing. With classful addressing, it's obsolete. This is something that we used to do with our addressing from about 1981 to I believe like 1993. That's when they introduced classless addressing. Now, as you can see right here, it says the network boundaries are fixed, 8, 16 to 24 bits. I'm not going to get too into the IP addressing. If you study CCNP, you should know that by now anyway. Classless addressing You got the uneven amounts, right? So let's go to these slides right here. This is the 8 slices that we gave to everybody. We didn't care what their appetites are. We just gave everybody a slice. Even the infant, we gave him a slice, right? This would represent VLSM. We changed the subnet mask. That's why they call it variable length subnet mask, because we sliced some bigger than others. We made some smaller than others, etc. And we gave everybody the right amount, because when you're thinking of an organization, we're not going to have a department that has exactly 50 for the accounting department, exactly 50 hosts for the help desk department, etc. We going to have different sizes of departments. So when we are separating our departments, we use VLSM to kind of not waste any addressing space and make sure it's the right amount of addresses that are being given out. The Unicast addresses, the broadcast addresses, etc. Let's move on to packet traces so I can show y'all the difference in the broadcast traffic, Unicast traffic, as well as the multicast traffic. You probably already noticed by now. If this is something that's kind of elementary to you, you can go ahead and skip. Go ahead and brush your teeth. You can skip this video, turn it off, whatever the case may be. But I'm going to go over it anyway. Wasn't going to do this. I was just going to cut it short. But I said I'm going to just do this just in case some people stumble upon this video and they just need maybe a little refresher. All right, so we got packet tracer loaded up here. I'm going to zoom in a little bit more for y'all. This is the topology. We got 3 hosts on the local area network. We got our switch, and we got 3 routers here, right? First, let's bring up the instructions. This came from the Cisco Academy, Learning Academy. We're going to first generate Unicast traffic, and we're going to kind of study its or investigate its traffic and what it do. It's simple. It's just sending from one host to another. So in the instructions here, it says click PC1, go to the desktop, command prompt, and ping 10032. I believe that's router 3. Let's go ahead and bring him up. Make sure we're in simulation mode. Bring the desktop, command prompt, ping 10032. We got him waiting right there. Let's go ahead and fast forward. I believe, again, that's router 3, that address. Fast forward. Router 1. It goes to router 3. Back to router 1. Back to the switch. And back to PC1. That's it. That's Unicast traffic there for you. All right, so let's move on to broadcast traffic. Basically, what we're going to have to do is create what's called a complex PDU. This is kind of like a representation of extended ping, if you know what that is. That's basically, you can change the source address. You could just kind of make it, you can modify the ping packet, basically. So let's go ahead and bring up complex PDU, PC1. And as he says here, generate broadcast traffic. Destination address is 255.255.255.255. That is a broadcast address. Now there's different broadcast addresses for different subnets. If you need help with that, I used an app called Practice Subnetting. If you have an Android phone, God forbid if you got an iPhone, I don't know if it's on there, but for an Android, you do Practice Subnetting in the Google Play Store. That is one great app that helps you learn about subnetting and how to do it in your mind really quickly. There's also subnetting.net. I'll post the links in the description below. That's the best way to subnet. And remember, different networks got different broadcast addresses. That's how I learned them. Download those apps. Go to that site. Subnetting.net is a great one because it has a game on there that helps, make it more fun. This is a well-known broadcast address. We're going to put sequence number 1, one shot times 0, and create the PDU. So, move right along. We're going to send the ping. A broadcast address. It goes to the switch. And notice the switch, it goes to all of its ports right here, to PC2, to PC3, and router 1, except from where it came from. When you broadcast, it doesn't send it back. It just sends it everywhere except from where it came from. That's a broadcast address. Let me show y'all multicast. All right, so here goes some EIGRP traffic. You got router 3. You see this orange router right here, right? I mean, this orange packet right here, or yellow, whatever you want to call it, mustard. All right, so fast forward. It goes to router 1. He's sending him a traffic. He's sending him just him traffic, right? And it checked out. You see that little check mark right there? It arrived where it needed to. Let's do another. Let's go fast forward one. Another packet from router 1 to router 2. That's basically kind of like a routing update, or it could be a hello packet. Let's open up the packet and see what it is. All right, this is the IP header right here. Where did it go to? Destination IP 224.0.0.10. What IP address is that? It's a multicast address right here, as you can see. The multicast address range specified by RFC 1112, I'll put a link in the description below, is from the 224.0.0 range to 239.255.255.255. Say that 35 times. That is the IP address range for multicast addressing. That's what that address, that's an example of that there. So, I think we went over everything we needed to as far as this goes. Not too much hands-on. We identified IP address types. We didn't really configure it. Y'all want me to show y'all how to configure an IP address on an interface? You just go to global config mode, configuration T, put IP space address, and then the IP address. And verifying it, you do a show interface and then the IP address. I mean, it can't get any simpler than that. That's basically it. If you like this video, comment, like, subscribe. If you don't like it, oh well. Thank you for watching the network.